Hi, and welcome to this lesson on quadratic equations. So let me just give you a heads up about each of these lessons. This lesson is aimed at GCSE maths students. However, that doesn't mean that somebody in Key Stage 3 or somebody at the start of A-level couldn't watch this and pick up some hints and tips on how to solve quadratic equations. Now, this lesson also has an accompanying worksheet, and I absolutely encourage you to, when you have finished this lesson, go away and try the problems, because maths is all about practice. It's okay understanding it when I'm going through it, but it's really important that you can take the principles we're going to learn today and apply them to unfamiliar questions. So there is a link in the bio of this video to the free worksheet that accompanies this lesson and the answers to that worksheet. So have a go at that after the session and make sure that you mark your own work as well. So quadratic equations. What is a quadratic equation? Well, a quadratic equation is any equation with a squared in it. So a great example of a quadratic equation, and one that you might all be familiar with, is something along the lines of x squared plus 8x plus 15. That's an example of a quadratic equation. And that's one that we should all now be a little bit familiar with. So how do we solve a quadratic equation? Well, there are two methods we can use to solve it, and we're going to cover both of them today. I'm just going to finish off making it a little bit better there. Now, the first method is by factorizing. Now, factorizing, as a reminder, is when we put our algebra back into brackets. So factorizing and expanding are terms that you might have heard. Factorizing is putting something into brackets. Expanding is taking it back out of brackets. So we are going to factorize this quadratic equation. Now, factorizing quadratics starts off relatively simple, and it can get much, much trickier. And we're going to look at some trickier examples. But to begin with, we need to think about a number that adds together to make 8, and two numbers, sorry, that add together to make 8 and times together to make 15. Now, if you're not feeling very confident, a great place to start is to write out the factors of 15. So the pairs of numbers that multiply together to make 15. So you could have 1 and 15, and 3 and 5. And luckily for us, that's it. There are no other pairs of numbers that multiply together to make 15. Do either of those add up to 8? Well, yes. 3 add 5 would give us 8. So what that means is, in our brackets, we're going to have x's in each bracket. The x's are going to give us the x squared, because x times x gives us x squared. One bracket is going to have a plus 3, and one bracket is going to have a plus 5. Now, I'm not going to go into factorising in too much detail. I will cover that in a separate lesson, but that is how we would factorise our quadratic. We can then solve it by making each bracket equal to 0. So we can say, I'm going to write it up here for space reasons, that x plus 3 is equal to 0, or x plus 5 is equal to 0. Why can we say that? Well, because those two brackets are multiplying together to equal 0. And the only way we can multiply numbers to get 0 is if one of them is a 0. So we look at if either bracket was equal to 0. We can now rearrange to say, if x plus 3 is equal to 0, what plus 3 would be equal to 0? Well, x must be minus 3, because minus 3 add 3 would give me 0. In the same way, I can say that x is equal to minus 5, because minus 5 add 5 would be equal to 0. Now, if you followed that, we're now going to have a go at a slightly trickier one. Okay. Hopefully, it's all come flooding back how we solve quadratic equations. So let's have a go at a slightly trickier one. And the reason this one is trickier is we're going to include some minus signs. Yeah. Okay. X squared plus 3x minus 10 is equal to 0. Now, feel free to pause the video right now and have a go at solving that equation yourself. In a moment, once you've had a go, unpause and I will run through the solution now. So we know that our brackets are going to contain x and x to make the x squared. And remember, we need two numbers that add together to give 3, but times together to make minus 10. I'm going to write out my factors again of 10. So 1 and 10 and 2 and 5. But this time I know that one of them is negative. Why do I know that? Well, the 10 is negative, which means one of the numbers must be a positive and the other one must be a negative. Remember, if the signs of the two numbers I'm multiplying are the same, then the answer will be positive. If they're different, then the answer will be negative. A positive times a negative gives a negative. It's the only way we can get a negative number by times it. So I'm looking at my numbers and I'm thinking, well, one of them is a plus and one of them is a minus. And hang on a minute, if I did plus 5 minus 2, that would get me my 3x. And so I know that in my brackets, I've got x plus 5 and x minus 2. I can now make each bracket equal to 0. So I can say x plus 5 is equal to 0 and x minus 2 is equal to 0, which means that x is equal to minus 5 or x is equal to 2. And there we have it. I have solved that equation. Now, again, there's one other way it can get even trickier. And that is when we have a number in front of the x squared. So we're going to have a go at one of those and we're going to solve that. And then we're going to look at the other way that we can solve quadratic equations. So if I have 6x squared plus 13x minus 5 is equal to 0. Now, this is a tricky one. Please feel free to pause the video now and have a go at solving this yourself, because I'm about to go through the solution. So it's trickier when we have a number in front of the x squared, but it's not impossible. The first thing I do, and I appreciate there are a few different ways to solve this, but the first thing I do is I think, how am I going to get 6x squared? Well, I could either have 6x times x, or I could have 2x times 3x. How do I decide which one it is? Well, I don't know at this point, so I'm just going to jot down that I could have 6x and x, or 2x and 3x. The next thing I'm going to look at is that minus 5. Remember, I need the two numbers in the brackets to add to make 13, but times to make minus 5. And again, we've got a minus in there. So we know that one of them is positive and one of them is negative. And you're probably thinking, well, the only numbers that times to make 5 are 1 and 5, and there's no way they're going to add up to 13. That is because our numbers are going to be multiplied by the 2x and the 3x to make the 13x. I told you it was going to get confusing. So realistically, let's have a look. If my numbers in my brackets, one of my numbers in my brackets is going to be a 1 and the other one is going to be a 5. We don't know which is positive or negative at this point. That's okay. We know that I'm going to have some x's. We just don't know how many. Now, if I had 6x and x, let's say I put the 6x here and 1x there, then that means I'm going to get 6x times 5, which is 30x, and 1 times x, which is 1x. Well, there's no way I can add those or subtract those to make 13. If I put if I put the 6 in front of this one, then I'm going to get 5x from the x times the 5 and 6x. Again, there's no way I can subtract those to make 13. I don't think it's going to be the 6x. I think it's going to be the 2x and the 3x. Let's have a go at that. So 2x times 5 would give me 10x, and 3x times 1 is going to give me 3x. Again, there's no way I can subtract those to make 13. So it must be 3x and 2x. 3x times 5 gives me 15x, and 2x times 1 gives me 2x. Yes, if I subtract those, I get 13x. Which means it must be plus 5 and minus 1 to give me plus 15x, take away 2x. If I now make each bracket equal to 0, I can solve that equation. And again, if you're struggling with the factorising bit and following all of that, factorising will be covered in a separate video. So do not panic if you're struggling to follow the factorising. I'm also going to show you there's a backup if we're struggling with factorising. So I can make 3x minus 1 equal to 0 and 2x plus 5 equal to 0. This is the same as saying 3x is equal to 1, and so x is equal to 1 over 3, or a third. This is the same as saying 2x is equal to minus 5, and therefore x is equal to minus 5 over 2, which is the same as minus 2.5 if we wanted to put it as a decimal. And we have now solved that quadratic equation. Now, the other way we can solve a quadratic equation, let's say we were struggling to factorise that one because it was particularly tricky. The other way we can solve a quadratic equation is by using the quadratic formula. Now, the quadratic formula is x is equal to, feel free to pause and have a go and see if you can remember it, minus b plus or minus the square root of b squared minus 4ac all over 2a, where a, b and c are, a is the number in front of our x squared, b is the number in front of our x, and c is the number you add on to the end of your quadratic. Remember, if we have minus signs, they come along too. So for example, if I have 3x squared minus 2x plus 7, I don't even know if that's solvable, I've just made that up as I go along. The b would be minus 2. The minus comes along with the number. So let's have a go using that formula. Jot it down if you haven't already, because we're going to have a go at using it. Using the formula, can you solve the equation x squared plus 3x plus 1 is equal to 0? Pause the video now and have a go by yourself. Here is the solution. My a is 1 because there's nothing in front of the x squared. My b is 3 and my c is 1. Now we can use a calculator, but we're going to hold off on just chucking everything into our calculator, and I'm going to explain why in a second. Because if I can say that x is equal to minus b, so minus 3, plus or minus the square root of 3 squared minus 4 times 3 times, no, not 4 times 3. Gosh, I can't even substitute right. See, teachers aren't perfect. 4 times 1 times 1. Oh my goodness. All over 2 times 1. Now, the reason we're not just going to chuck this in our calculator is because minus signs play havoc. Now, this one is quite a nice one. If we've got minus 3s and minus this and minus that, by chucking it all into our calculator, you end up with about 12 brackets going on. And then your calculator throws up a math error because you've forgotten to close a set of brackets and it becomes a whole mess. So it's easier, or trust me, to do a tiny bit of working out first before we plug it straight into a calculator. It also means if you make a mistake putting it in your calculator, the examiner will still know that you knew what you were doing and be able to award you some method marks. So don't just run straight for let's put it in the calculator, because if it goes wrong, you're going to have to go back to the beginning anyway. So we're going to simplify this a little bit. We're going to say minus 3 plus or minus the square root. Well, 9 is 3 squared, and 4 times 1 is 4. So 9 minus 4 is 5. So the square root of 5 all over 2. Now, if we were asked to give this in an exact form using surds, that could be our answer. Our two answers would be x is minus 3 plus root 5 over 2, and x is equal to minus 3 minus root 5 over 2. However, if it asked us to give our answer to a certain number of decimal places, then we can just chuck those two things into our calculator and it will give us our answer, which we can give to the appropriate number of decimal places. Excellent stuff. Now, if we're very lucky, we will get a question in the exam that just asks us to solve a quadratic equation. Brilliant. We can try factorising, which is the easiest way. And if we're struggling to factorise, then we can just plug the numbers into the formula. However, not every exam question is that straightforward. And often we need to set up our own quadratic and then solve it. So we're going to have a go at a couple of those now, and there are some more examples on the worksheet for you to have a go at. Let me share with you this first question here. I've lost Zoom. There we go. I lost Zoom for a second. Not very good. Okay, so no, let's zoom this in. The plan below shows a large rectangle of length 2x plus 6 meters and width x meters. A smaller rectangle of length x meters and width 3 meters is cut out and removed. The area of the shape that is left is 100 meters squared. Show that 2x squared plus 3x minus 100 is equal to 0. So, by all means, pause the video and have a go at this yourself. I'm going to talk you through the solution now. So, the first thing we're going to do, if this wasn't an algebra question, if we'd been given actual numbers, we would work out the area of the shape that is left by doing the area of the bigger rectangle, the whole thing, minus the bit that is cut out. And we should all be familiar with that method now. The only added complication here is that we've got some algebra, but our method is going to stay exactly the same. So the area of the big shape, before it had something cut out, is going to be its length times its width, which is the same as, oh, I need to annotate. There's no point me prodding at the screen if I'm not annotating, is there? We've got x multiplied by 2x plus 6. That's the area of the full rectangle. The area of the bit that we've cut out, well, that's exactly the same. We just need to do the length times the width, which is the same as 3 times x. So that's 3x. Excellent stuff. Now we know the area of the big bit minus that is equal to the area of the shape that is left is 100. So we've got x bracket 2x plus 6 minus 3x is equal to 100. Okay, what are we going to do now? Well, we're going to expand that bracket and we're going to hope that that all simplifies down to what we've been asked to show. So if I expand that bracket, I get 2x squared, that's x times 2x, and then x times 6 gives me 6x minus 3x is equal to 100. Okay, we're looking good, we're nearly there. We've got the 2x squared, we know we've got the 100 in there. 6x take away 3x is going to give me 3x, and so I end up with 2x squared plus 3x, and all they've done is move the 100 over to the other side, so minus 100 is equal to 0, which is exactly what they asked me for. Perfect. Now, the minute they ask you to set up a quadratic equation, you can predict that they're going to ask you to solve it. Now, calculate the length of the smaller rectangle. Give your answer correct to 3 significant figures. That usually means we're going to get a horrible decimal, which implies this equation is not easily solvable by factorising. It's also worth 4 marks. So I'm going to just plump for putting it straight into the formula. Have a go at doing that now, and I'm going to walk you through the solution. So again, I've forgotten to press annotate. A is equal to 2, B is equal to 3, and C is equal to minus 100. Remember, x is equal to minus b plus or minus the square root of b squared minus 4ac, slightly wonky square root, all over 2a. And again, we've got minus signs there, so don't forget, it's often easier to not just chuck that straight into a calculator. So if we're going to simplify this a little bit, we've got minus 3 plus or minus the square root. Well, 3 squared is 9. So we've got 9 minus 4 times 2, 8 times minus 100, minus 800. So that's going to be plus 800 all over 2 times 2, which is 4. So we've got minus 3 plus or minus the square root of 809 all over 4. And then we can just chuck that into our calculator. And I know it's a bit of work to do it up front and work out the square roots and things, but it does make it easier to put it into our calculator, and it means you're less likely to make a mistake. And so what we get is we get x is equal to 6.36, or we get x is equal to minus 7.86. Now it's important we write down both solutions. It's also important that we state that that one cannot be possible because we cannot have a negative length. And so the length of the smaller rectangle, x, is 6.36 to 3 significant figures. See, it's no more difficult than solving a regular quadratic equation. We just have that initial step of we have to set it up first. And there's loads of practice of that in the worksheet. Now, the final one, that's a slightly weird setup, it's not a real life scenario one. This is the one where we have to solve a slightly strange looking equation. And again, there's an example of this. you'll have seen these in past papers. There'll be like a simplify or a solve or a rearrange. Now, if we have an algebraic fraction question, the first thing I'm going to do if it's a quadratic is factorize it. I'm going to factorize it and try and simplify it out. Now, this isn't what I'm going to do here. This one is slightly different. And again, there's plenty of practice of this in the worksheet. So feel free to pause now and have a go at this question. Here is the solution. So there's a couple of different ways we could approach this question. I think the most straightforward is to get rid of the fractions. I hate fractions. They're a nightmare. So the first thing we're going to do is get rid of the fractions. How do we do that? Well, we're going to times both sides of the equation by everything that appears on the bottom of a fraction. So we're basically going to times, oh gosh, I've done it again. I'm managing to annotate without putting the annotation on. I feel like that's going to become my catchphrase. So we're going to times both sides of the equation by 2x plus 1. X over 2 times 2x plus 1, well, the 2's are going to cancel. So I'm going to get x plus 1 minus, the x plus 1's are going to cancel on the second fraction. So I've got 2 times 2 is equal to 1 times 2x plus 1. And all I've done is cut that a little bit. So instead of saying x times 2x plus 1 over 2, and then cancelled out the 2's, I've just skipped that step a little bit ahead. But by all means, feel free to write down that first stage of working. I've just tried to save a little bit of space by realising that those 2's cancel. Next, I'm going to expand all the brackets out. So I'm going to get x times x gives me x squared, plus 1 times x gives me x, minus 2 times 2, which is 4, is equal to 2 times x, which is 2x, plus 2 times 1, which is 2. I'm now going to do what everyone loves, which is gather like terms. So I'm going to move everything to one side of the equation and collect everything together. Now, it doesn't matter which side of the equation you pick, but I always think it's easiest to leave the squared, the x squared bit as positive, because it just makes it easier to solve. So I'm going to leave that as x squared. I'm going to move the 2x to the other side, so that's going to be x, take away 2x, which is minus x, and I've got minus 4, take away that 2, gives me minus 6, is equal to 0. Now I need two numbers that times together to make minus 6 and add together to make minus 1. Well, 6 is either going to be 6 and 1 or 3 and 2. 3 and 2. That might work. So I've got x and x is equal to 0. I'm going to need the 3 to be negative because I end up with minus 1. Minus 3 add 2 give me minus 1. And so making each bracket equal to 0, x minus 3 equals 0, or x plus 2 is equal to 0. And so x is equal to 3, or x is equal to minus 2. And there we have it. We have solved that equation. That is everything for this lesson. That was a whistle-stop tour through quadratics. I've assumed that you are familiar with factorising and the quadratic formula. If you are not, then I will be going through factorising in particular in more detail and some more algebra stuff in some other videos. But please, please, please go and have a go at the worksheet. It's free. The answers are provided. It will really help you to reinforce quadratic equations and what the questions will look like in the exam. If you found this video helpful or you have any comments or suggestions for further topics, feel free to pop them in the comments. Also, please share this. far and wide, and I will see you again soon for another lesson. Thank you for watching and have a great rest of your day. Bye.